All right. A very good afternoon to everybody who have joined in for today's masterclass. So, a quick introduction for people who haven't been here. This masterclass is run by AntWak. AntWak is an edtech company that is currently in offerings of multiple courses, including cybersecurity, digital marketing, and data engineering. We have been doing bootcamp courses for around 16 weeks, wherein we cover about 10 to 12 topics. I'll be sharing a link with you guys in the chat window. So do feel free to go ahead and check the link out, and that will contain some promotional discounts. Coming to our host, our expert today, Mr. Rakshit Vidyarthi. So this is his second session with us. Rakshit comes with a domain expertise around networking security, and he's been into the industry for almost close to a decade. He comes with a range of accolades or certifications from Fortinet, and he has also been working with big companies, not limited to just Fortinet, but also he's worked with other companies like CSS Corp, and he's been a pioneer in the networking arena for quite some time. He also comes with an ocean of certifications, including the CCNA ones. So today's class, we're going to discuss more on the lines of Wireshark. So without any further delay, I request everybody of you guys to welcome Rakshit to AntWak. Rakshit, the class is yours. Cheers.
Thank you. All right, everyone, good afternoon. So I think you've already got to know about a little bit about myself. So my name is Rakshit Vidyarthi, and I have around 10 years of experience in this field of network and network security, handle cybersecurity as well. So let me make it very crystal clear for everyone in this session that we have. So when we talk about Wireshark, right? So a lot of people who are basically working with me, or who all the engineers who have worked with me in the last decade, there's one thing which I've already seen, that all the engineers, when it comes to troubleshooting, okay, they kind of lack the logic behind how do I proceed with the troubleshooting, how do I make sure that if in case there is an issue, how do I pinpoint that issue? All right, so those kind of questions always come up to me, that sir, how would I basically approach this kind of an issue? And let's say, for example, there's always a fight between it's an issue with the network, and the network would basically say it's a problem with servers. Server team would basically say, hey, you know what, it looks like a problem with the firewall. So basically it's just a blame game. But the point is, when it comes to you being a network engineer or a firewall engineer, how can you verify, take some facts, pick up the information, and prove that is it a problem on the network or on the firewall, or is it not a problem with the network or the firewall? How would I do that? That is where basically comes Wireshark. Wireshark is basically a software which is used for packet sniffing on the network, that helps you understand what exactly is going in the network, how the traffic is flowing through your routers, switches, firewalls, servers. Doesn't matter, any device which has a network connection or can be connected to the network, you can tap into it and you can take a capture to it. Okay, so that's the whole point of taking a capture, to understand how well your network is working, and if in case something goes wrong, how do you troubleshoot, how do you fix the problem, and get some facts to understand that is it a problem on the network or is it not a problem on the network. That's the whole idea or the concept behind using the Wireshark as a software. Okay, so let me quickly go ahead and share my screen. Let me go ahead and tell you what exactly a Wireshark looks like and all that stuff, in case you guys are not aware of that. And then we'll go ahead and dig deep into how do you open, how do you capture information, how do you look into the information. This is what we are going to cover in today's topic. All right, so hardcore technical is the only thing which you can expect from today's session. Okay, so let me go ahead and share my screen over here. All right, so I believe you should be able to see a blank screen.
Your screen is available. Yeah.
Okay. Okay, all right. So let me open up a browser. Okay. All right. So just go ahead, Google Wireshark. Okay. So you will get this kind of a page where you would see the first link, which is called as Wireshark Go Deep. Okay. So let's just go ahead and click on it. Okay, see, so this is the home page of Wireshark. This is the place where you can go ahead and download the software for you. Okay, so you can click on the download and this the software will start downloading for you guys. Okay, now once you do that, there are a couple of things that you need to know about how exactly the Wireshark works. But before we go ahead and understand how exactly you look into the look into the Wireshark, and what do I have to look into the Wireshark, right? Let's just do a couple of questions, a little bit of interactive session on, you might have heard about a model which is called as an OSI model. Now, why do I discuss the OSI model? Since we'll be working in troubleshooting a lot of concepts about the Wireshark, we should know what exactly the OSI model is, because that is the that is the pillar on which we will be going and making our building, right? So coming back to the the dashboard, and let's talk about a little bit about the OSLR. Okay, now we'll keep this as a little bit of interaction. Okay, so whenever we are working with the networking, or anybody who is basically into the networking field, right, everybody has gone through either CCNA, right, or they might have gone through a certification which is called as the N plus, or more aptly CompTIA Network Plus, right? So this is the basic which every engineer has to go through before it makes sure that it is getting a job into the networking field, because it's like the ABCD of network. All right. So CCNA talks about a concept of OSI model. Now, do you guys have permission to unmute yourself? If in case no, you can basically put in the chat window, what exactly is an OSI? Anybody knows what is the full form of the OSI? Go ahead, put it in the chat window. If you do not know, you can also go ahead and say no, not aware of. So Pooja says open system interconnect, Sai, Naresh, Gorang, technical, Sakshi. Okay. All right. So I think a lot of people already know this. So good to know that. Now OSI model, just to give you, a little bit of a one-liner answer. This model basically tells that if you have a PC, okay, and let's say for example, you have a Wi-Fi. All right. Let's say for example, you have a smart TV, right? So I'm not sure of the people, but the TVs are smart. And let's say we have a mobile as well. So all of them are connected nowadays, are connected to your home Wi-Fi. I mean, every home nowadays in the metropolitan city, every home have a Wi-Fi. Every device is basically more or less some way or the other connected to your Wi-Fi, right? So how is this PC connected to the Wi-Fi? How is this smart TV connected to the Wi-Fi? How is this phone connected to the Wi-Fi? The OSI model basically tells you that how is this communication happening between two devices. All right, that is why it is called as a network. Okay. All right. Now, so whenever we say we are talking about a network, so whenever we are, am I audible? Yes, I think yes. Okay. All right. So whenever we are talking about the networking, right, we always think about devices. All right. And those devices are able to understand and communicate with each other, right? So how do I do that? With the help of something which is called as the OSI model. Now, let's say if anybody can put in the chat window, how many layers do we have in the OSI model? Oh, great. Before even I can finish up my question, a lot of people have said, wow, 8. Who is that? Okay, so no, not 8, but I would say most of you have given the right answer of 7. That's absolutely right. Okay, now 7 is the number of layers that you have. Now go ahead and tell me what are the layers. Let's just keep it more interactive. What is the first layer? So there's no first layer as such because it depends on uh, from which direction you are looking for. All right. So if, let's say, for example, you're looking from the top, then application layer is the top layer. If you're looking from the bottom, then the physical layer is the first one, right? Doesn't matter what's the first one. What matters is you should know all these 7 layers, right? Okay. So Ratna, I think, has the same so PDNT SPA. So this is what I have also learned. This is how I have learned PDNT SPA. Physical, data link, network, transport, session, presentation, and application, right? Let me see if I have an image for you guys. Or, yep, okay. Hope you guys are able to see this. Okay, now see, it's quite simple enough, right? All of you guys who are working with in the networking field, all of you guys know this, that when we are working with the OSI model, we are talking about 7 layers, and the communication always happens. Let's say, for example, if this is the PC, right? And let's say I make one more PC over here. If I need to communicate with this PC, the traffic will go which direction? Downwards, right? Okay, so application, from application to presentation, session, transport, network, data, physical. Then in the physical, it's all bits and bytes. And then again, way to the up, right? That's how you go. So this is how normally how the traffic or how the data is being sent over from one layer to the other layer, right? Now, if you go and look into what exactly each layer does, end user layer, HTTP, FTP. So these are all the protocols which work on different layers. Presentation is SSL, SSH. Session is synchronization, API, sockets. Transportation is TCP, UDP. A network engineer's 80% of the job is over here and over here. 80%, I'll not say 100%, because nowadays there's a lot of things coming up, APIs, coding, and a lot of other things are, Python, automation, there's a lot of things going on. So I would say, there's 70 to 80% your job is over here, but then slowly and gradually we are going to the application as well. Okay, if anybody has gone through the latest CCNA, you would feel that, there's a lot of automation coming in the CCNA course curriculum as well, right? So frames, physical structure in the physical layer, okay, fiber cable, wireless hubs, repeaters, and that is it. And that is how the each layer functions and how exactly the communication happens. Okay, this is just a very small introduction on the OSI model. We'll not dig deep into it because I think my last session was all about OSI layer, right? So if anybody wants to understand how this OSI layer model, basic networking, basic communication, how does all these things work, they can go back to the AntWak's YouTube channel, and you would be able to find my session on the communications. So we'll not dig deep into the 7 layers, but just a quick introduction of what exactly these all things does, right? Okay, now moving to a little bit on communication. So network traffic, right? Packet traveling. How does all these things work? See, whatever company that you work for, whatever project that you work for, whatever client that you work for, every client has a network, right? They might have certain firewalls in place. They might have certain let's say, for example, you have PCs connected, right? You have a switch connected, you have server, right? You have the routers in place, right? You have, let's say, an L3 switch in place, and then you have a different network altogether. Let's just say this is an MPLS connection. It does not look like it, but then let's just say it's an MPLS connection. Okay, my point over here is that let's say I am handling traffic for the company abc.com. Okay, there's a guy who is basically sitting on PCA and he wants to talk to PCB. Now PCA is on a different network altogether. Okay, network D is a different network, right? So let's, for example, this guy is on 10.0 1.1.1. This guy is on 192.168.1.1. If this guy needs to communicate with this guy, let's just say there was a problem. There was some problem in the router and it was not forwarding the traffic as it is supposed to forward the traffic. All right. A lot of troubleshooting happened and we were not able to pinpoint what exactly the problem was. Then what would we do? Okay. So Wireshark is one of the softwares which basically help you understand that how exactly these things are work. See, because what happens is when it comes to a router, you cannot take a packet capture over there. When it comes to a layer 3 switch, you cannot directly take a capture on the switch. I mean, there are multiple ways of doing it, but you cannot directly take a capture on the switch or on the router. You can make it happen either on a Windows machine or maybe on the server or maybe on the firewall. Okay, but not on a layer 3 device such as a router or a layer 2 device such as a switch, right? So let me go ahead and show you that. Let's say, for example, you open up your Wireshark. You have installed the Wireshark in your machine, and now basically you have opened it up. This is the first page, or you can say as soon as you open this up, this is how the Wireshark would look like in as soon as you open this software. Okay, now it's basically going to show you, maybe certain captures which you have opened maybe recently or maybe a few days back. It's going to show you that information. Apart from that, it is going to show something which is called as the capture. Okay, over here it will basically show you all the interfaces that you have on your Windows laptop or whatever server that you are on. Okay, now let's say, for example, I'm not able to, I want to understand how the communication is happening from this machine to the internet. Okay, now tell me one thing. If you guys are all working in the networking, have in your career experience in the networking field, has anybody got a question from the interviewer? The interviewer says, hey, you know what? I open up my laptop, I type in google.com, and now tell me what is happening. Has anybody got this question? Say yes, no, maybe. Yes. Okay, a lot of people. Good, good, good. Okay, so there is a theoretical answer to it that, what happens first? DNS request, right? What happens next? DNS response. What happens next? HTTP request. What happens next? HTTP response, right? So how does exactly all these things are? It's like theoretical knowledge of, okay, I know this, that, okay, this is how it is supposed to work. But let's do one thing. Rather than thinking or theoretically understanding it, let's just see how exactly this thing works. Okay, I'll go ahead and show you that when I type in a URL, what is my system doing right now? Okay, is it launching a DNS request? Is it launching HTTP request? What information is going? What response is coming back? All this information we would be able to see with the help of this particular software, which we call as Wireshark. Okay, so what do we do? If in case, if in in our case, if you need to take a capture, you need to first of all select the interface or the Wi-Fi adapter. Or if you're connected to an Ethernet cable, then maybe the Ethernet cable that you have. So I have a local area connection 9 and 3. I do not use these, so that is why you are seeing this blank, no traffic at all. But then if you look into the Wi-Fi, okay, you can see some, it's like a living network, a little bit of heartbeats going on, right? So we'll go ahead and double click on this. And as soon as I do this, you see this, it's all real time. What is happening is that right now my machine is trying to communicate with an IP address of 134.224, 133.45, and there's a lot of communication going on. So I can only guess that it might be something have to do with the connectivity that I have, maybe Zoom IP address, maybe. But this is all real-time capture being taken from my Wi-Fi adapter. Okay, all the communication which is happening on my system, on my laptop, Wireshark is taking a blank capture. So everything is being taken, everything is being captured, and it's being shown on the Wireshark software. Right now, let's do one thing. I'll go ahead and let me open up a browser again. Okay, Now what I'm going to do is I'll open up and I'll say there was a website I wanted to show you. Okay, got it. Okay, so this is the website that I wanted to show you. It's Gaia csusmass.edu Warshak Lab alice.txt. It is HTTP traffic. The reason I took the HTTP traffic was that it is plain text, so I would be able to show you something on the Warshak capture. So I'll go ahead and hit enter. Okay, all right, got the page. It's basically the story of Alice in the Wonderland. If in case anybody is interested, go ahead and read it out. But we are not there for the story. We are here for the capture. Okay, all right. So this is the capture. It's going on. It must have taken some captures. I'll stop it. How do I stop? This is the button, red. Okay, stop capturing the packets. So Omkar has a question. Is it possible to capture the HTTPS request in the Warshak? It's absolutely possible. I'm going to show you. I'll just remind me in maybe 15-20 minutes. I'm going to show you that as well. Okay. Now, so this is the capture that you see. Okay. Once you have it, I'll have clicked on stop because I have already visited the website. Okay. Now I do not want to, take further captures because that is irrelevant. What I just want to see is that the website that I have gone to, can I see any information with respect to that particular website on this particular Warshak capture? And I'm going to tell you why is it relevant. See, what you do is you go ahead and say Control F. Okay, so there will be a a small window coming up, and it is basically asking you what exactly are you trying to search. Make sure that you have the regular expression over here. I mean, there's a lot of different columns of display, filter, hex value, string, but we are concerned with the regular expression. Why? Because we are looking for the URL. I want to search the URL. So regular expression GAIA, okay, and enter. Okay. All right. So let's see if you're able to see this. Okay. Look at the packet number 415 that ends with 41527, the first packet. Okay. Now, what do you see? Let me make a little bit of distance over here. Yeah. Okay. All right. Now, what you are seeing over here is basically the information about the packet number, which is the first column. The second is the time. Now this, the display of time, you can basically change it in the view section in the time display format. You can see whatever, format which makes sense to you. Okay. Let me see. See if I do this, then you are getting the time format in a different way, but it's basically showing you exactly how. Go ahead and what is the date, the time, the month, it's 12:20 and the time frame, right? So it's absolutely on you how exactly you want to have the time format. No problems at all. Now let's look at the third column, which is the source. Okay, now how will I know that what's the IP address? Okay, can anybody tell me, if I want to know the IP address of my machine, what is the quickest way of finding the IP address? Who just says ping? No. Salwa Kumar says ipconfig. Yes. So what I do is go into the command prompt quickly, ipconfig. That is it. Enter. See what is the IP address? 192.160. If config Sri is basically for the Linux machines, ipconfig is basically for Windows machines. Okay, you were right, but the platform was wrong. Okay, all right. Now, absolutely right, Preetham. So IPv4 is 192.168.0.3. So what do we see over here? Source column 192.168.0.3. Absolutely right. So I know that, okay, the traffic that I'm seeing over here is getting originated on my machine, or my IP address is basically originating. Now, theoretically, we all know that whenever we are putting google.com or whatever website name that we are doing, the first thing is the DNS request, right? We know this theoretically, but let's just have a look into it. Okay, let's see from our own eyes how exactly this thing looks like in a network layer. If in layer 3, how does it look like? So you can see the destination is 1.1. What is 1.1? Again, ipconfig/all. What do you see? Not the gateway. This is the DNS server. My gateway is 192.168.0.1. See, the first thing, as I said, right, as soon as you put a URL, okay, as soon as you put a URL, all right, the first thing which happens is the DNS request, right? So first thing which my Windows machine is going to check is that what is the IP address of the DNS server, because I have to send this DNS request to that particular DNS server so that the DNS server would be able to give me the response back. That is the theoretical understanding. Now let's have a look. So 1.1 is a destination. Look at the protocol section, right? DNS. Look at the, sorry, I clicked on something. Okay, yeah, here it is. Okay. All right, the destination 1.1 protocol DNS. Okay, now standard query, and then you have some hexadecimal value. Then you have A. Do you know what this A is? If you have studied DNS as a technology, you would know that A over here basically means the DNS A record. Okay, now what is A record? See, A record is you remember in the past when we used to have dial tone phones, we used to have a phone book, right? And what does that on information it has? It has the name of our friends, relatives, and the number, right? So this is exactly what happens in the A record of the DNS as well, right? You have the information about the websites, whatever website that you're basically accessing, Google, YouTube, Facebook, Insta, Snap, whatever it is, doesn't matter. This is all linked to an IP address, right? So the DNS request is being sent over with this A record of gaia.cs.usmass.edu. Now let me do one thing. I'll extend this over here, stretch this up to the top. Okay. Now see, in the Wireshark capture, right? Oopsie. In the Wireshark capture, we just saw, that, we have something, the protocols, application, presentation, all that stuff, right? Then you have TCP, UDP, IP, frames, everything. Now look over here at the application level, we see the DNS, the presentation session, then the transport, fourth layer, third layer, right? Let's see the same information over here. You see the frame, right? The frame is layer 2. Then you see the Ethernet, right? So the frame header has the information of Ethernet. What does Ethernet has? Source MAC address, destination MAC address. Am I right or not? Yes or no? Everybody is able to follow this? Yes, good. Now, if you open this Ethernet packet, what would you get? You'll get the Internet Protocol, right? So now Internet Protocol has information about what? The source IP address and the destination IP address, right? Now, if I, what do you call that? Decapsulate the Internet Protocol as well, what would I get? The UDP packet, right? Now UDP, what is UDP? The source port and the destination port, right? Now if I decapsulate the UDP packet, I'll get which protocol? The application protocol. What protocol we are working with? DNS. Okay, so now with the DNS, if I decapsulate the DNS, I would actually be able to see the text, the data, the actual data which is being sent over. Okay, so if I open this up, okay, you see the transaction ID, right? 8683. So just this is a way of making sure that all the see, there's not just one DNS request which is going out. There are multiple DNS requests which is going out. So the system needs to know that what request is mapped to which response. That is why it has to have an ID. Okay, so for the website that we are accessing, the ID which was given was this 8683. All right. Okay. Now we have something which is called as a flag. Now flag is basically it's a DNS request, right? So you'll have a request flag, right? All right. Now let's go ahead and see the standard query. The question is just one question. The question says, what is the IP address? So look at the query section. So let me go ahead and open this up. It says gaia.cs.emsn.edu type A class IN. So class IN basically means in the Indian location, I want an IP address of this website. Okay. So if I open this further, I would be able to, okay, I would be able to see this information. Now name this, length, label count, doesn't matter, don't bother about this. Type A, see, this is what I was talking about, DNS A record. All right, so it is asking that, hey, hey DNS 1.1, can you resolve this name to an IP address? This is a request which is being sent over. Now Wireshark, what it does is it is also showing you, it's intelligent enough to tell you that, hey, you know what, the request which you are able to see, the response to that is on 41813 number packet. Okay, so if I go into the left section, the information was, or the packet number was 41527. Okay, now it says the packet response to that packet is on 41813. Now just think for a second, just take a pause, think. The packet number is 41527, right? So it's like 41,527 packet, right? What is the packet number for the response? 41,813. So in a way, it's like, more than, it's approximately 300 packets has been sent between this DNS request and DNS response. And have you figured this out? That as soon as I put the request, the website URL, right? Within a second, I was able to get the response and I was able to get the page. But you can see that in that second, there were 300 packets which is already being captured by the Wireshark capture. So there are millions of packets which is being captured per second, right? Now, coming back over here, what we are basically saying is that the DNS request wants to know or wants to get the resolution for this name Gaia. Okay. Now the Wireshark says, hey, you know what? If you want to look into the response, go to the packet number 41813. Now I'll just double click on it and it will directly take me to that particular packet number. So double click and here you go. Let me show you. See, 41813. Now you can see the source is 1.1 and the destination is 192.168.0.3. Does that make sense to you guys? The source was 192.168.0.3. The destination was 1.1 because this was the DNS request, but now we are getting the DNS response. So automatically the IP address gets reversed with the source and the destination, right? Everybody clear? Doubts? Good. Okay. Now what I'm going to show you over here is that 41813. Okay, if you double click it, it's basically, open up a new window and it's going to show you the same information, but I'm going to show you over here. Okay, so let's look over here again. So frame, if you can open this up, it's going to basically tell you information about, so time delta, do not bother. Maybe we can take another session for the Wireshark. Time delta is basically the difference between the packets. Okay, do not bother, that's fine. Okay, now it's going to tell you the protocol or the Ethernet, the type, what is being used. So you can know that the Ethernet type is IP, UDP, and DNS. So always remember, whenever you are learning OSI model, right? And I'm not sure if you have got this question, but normally my students have said that a couple of companies like TCS, Accenture, they did ask that how, if the the data is going from one layer to the another layer, how exactly the layer knows that which protocol it is coming with. See, this is the place where this is the player where the frame is telling the layers, hey, you know what, I have IP, I have UDP, I have DNS. Okay, you will not get this information anywhere else but on the Wireshark. Okay, and you can very well go ahead and say this information, maybe, if in case you're in the interview, you can basically say, hey, you know what, I can take a capture, and in the frame, I would be able to get the Ethernet type, the IP, and all the protocols which is being used. Okay. All right. Now, the next is the Ethernet. If you open this up, you'll get the information about the source MAC and the destination MAC. You can see that this is Intel, right? Then this is TP-Link. So basically, Intel is my adapter, and TP-Link is my gateway. Okay. Then you have Internet Protocol. So Internet Protocol is going to tell you the information about the source IP and the destination IP, and the IP header. Okay, whatever information that you would basically see in the IP header, you would see the same information over here as well. Anybody has heard about TTL, time to live? This is what TTL is over here, 58. Do you know what this means? It means, just to give, I mean, I know the full form, time to live, but what it means in, in just one line, absolutely right, Piyush. So it means 58 hops, meaning if the communication between my machine and the DNS server is more than 58 hops, 58 devices, I'm going to drop this packet. Okay, so basically I'll never get a response back. But fortunately, I haven't had to go through these many devices, so that is why TTL is 58. Okay, Naresh as well says the same thing, number of hops. So it's not hope, it's hop. Do not ummeed nahi deni hai. Okay, so coming back, see, this is the source address, the destination address. Okay, then you have the UDP. Again, I'll extend this, expand this. You get to know the source port 53. So I know source port 53 basically means it's DNS port. Destination port is the port that I started off, the client machine started off with this particular port. Okay, now I'll open up the domain name system. Just squeeze this so that you would be able to see. Okay, let me minimize all this. Okay, so domain name system, this is the response. Transaction ID C8683. So the system knows that, okay, I have a request for 8683. This is how the Wireshark also knows that the transaction ID matches. Okay, it's the response for this particular DNS request. Okay, all right. So now let's have a look into the answer section. So it also shows you that the query, what was the query made? Okay, and it's going to show you that the query was for Gaia, and I have the IP address of 128.119.245.12. Okay, so I got this information from the Wireshark that, okay, the DNS request was made for this particular website, and this is the response which I have. Okay, all right. Now what I'm going to do is that, let me lower this down. Okay, so I know what is the IP address, 128.119, right? So what I'm going to do is, now I'm going to basically search for an IP address which is 128.119.245.12. Okay, why do I need to search for this? See, because it's a website, right? I'm accessing a website. So the first thing was the DNS request and the response. So we know that, okay, this is the DNS, this is the response. I got the IP address as well. Now what is the next step? It's the HTTP request, right? So how would I see that? I just need to filter this 128. So I'll just scroll a little bit and see if I'm able to see this IP address 128. If in case you're not able to find that, the easier way is right click, apply as a filter, select it. Okay, if you do this, it is basically going to filter this. Okay, but since I used the DNS packet, it took up the frame for that particular packet. So what we do not have to do this. What you have to do is, what I know is that this is the IP address. So what I do is come over here in the display filter, put in IP dot ADDR, okay, equals double times, 2 times equals, okay, and then put in the IP address. So I have 128 dot 119.245 dot and enter. Oops. So and enter. So you can see this is a green, right? So green base. So if I see when I'm on the third octet, 245, it is going up in a little bit pinkish. So basically it's just telling you that, hey, you know what, the IP address is not yet complete, or the syntax basically is not yet complete. So if I do this dot 1 2, okay, now it is complete. So enter. Okay, now so basically it is trying to, is it filtering or is it searching packets displayed 0? Why? Okay, so for some reasons it is not showing the request. Oh, I know why. I know why. Okay, so since I before the session I already tried doing this just to make sure that you know that all the steps are fine or not. What happened was it got cached, right? So if it is cached, it is not going to show you. So what I do is I flush the DNS, right? So ipconfig, what's the command? Flush DNS. That's it. Successfully flushed the DNS resolver cache. Okay, so it is not going to take anything which is from the cache. Okay, what I have to do is I have to basically start the capture once more. No problem at all. Continue without saving. So I'm not going to save this. Continue without saving. Okay, see, capture started again. Okay, what I'll do is rather than using this, I'm going to use the incognito window. Okay, all right, so let me refresh this. This is an incognito private window, so no caching. Okay, refresh and up again. So I'll stop now. Okay, same process, Control F and Gaia. Okay, so I got the page, got the request, DNS response. Okay, hold on, response over here. Okay, all right, now let's have a look over here. The response is 128.119. See, instantly the immediate next packet is the packet for the request. Okay, now let's have a look. This is fine, packet number is fine, the time is fine, source, I know it's my laptop IP address. Let's look at the destination section, the green one. Look at the green one. Okay, TCP port number 33517, that's the source port, and this arrow basically means that it's going to the destination. What destination? Port number 80. Okay, anybody have, I think all of you have basically gone through the TCP, right? TCP three-way handshake, all of you guys must know, right? The first packet is SYN packet. What is the second packet? ACK? No, SYNACK, right? So what I do is, again, I cannot go ahead and just keep on finding, okay, this is the SYN packet, where is the SYNACK packet, where is it? There's a lot of packet going on. So what I do is, the best way is go ahead, right click. Okay, there's an option of follow. Okay, click on the TCP stream. Okay, now as soon as you do this, it is going to show you the result of it. Okay, so I can see that it's a get request. For which URL? That's the URL. What is the host? That's the Gaia, which I actually wanted to go to. Okay, and I can also, if I take this capture on the Wireshark or on the network, right? If I take this on the network or on the firewall, I would know that I am the user is basically using a browser. It is using Windows 9 NT10. NT10 is Windows 10, right? So I'll get to know that what is the browser that I'm being using. Okay, now it tells a lot of information about the time frame and all that stuff, and it's also going to show you that whether the response was positive response, I got the response or not, right? So anyways, I do not want to see all this. That is fine, no problem at all. I'll go ahead and click on close. Okay, this is the place. Click on close. Okay, now what do you see over here? Look at the filter. It says TCP dot stream. I'm not sure if I can zoom this up, but the TCP dot stream dot EQ, and it's 27. So this is the TCP stream 27. Okay, 27th TCP stream is the stream which is being used to access that particular website. Okay, so now the capture that you see, it's just a small capture, right? Because it is filtering out only the information for that particular website that I'm accessing right now. Okay, look over here. Do you see the first packet? SYN packet. Look at this third packet, 82.33517. It's a SYN-ACK. It is absolutely showing you that what exactly it is doing right now. Okay, third acknowledgement. Do you see the three-way handshake? We have always seen the handshake in an image on a notebook or maybe on a book or maybe some theoretical sessions going on, but this is actually happening right now on the Wireshark, on your network. Okay, so if you open this up, you would be able to see the information. Look over here. Let me show you the SYN packet. Acha, tell me one thing. Quick question. If anybody asks you in the interview, and people do ask, if in case you're going for a L2 position or an L3 position, if in case somebody asks you, do you know three-way handshake? What's the first thing which you will going to tell you? My screen not visible. Guys, can you see my screen? Yes, no, maybe? Yes. Okay. All right, cool. Okay, so coming back to the question. If in case the interviewer is asking you a question, do you know TCP handshake? What is the first thing you will say? Yes, I know, right? But if it says, okay, tell me the first packet, you say it's a SYN packet. And then the interviewer says, okay, tell me more. What is the first packet? What information does it go in the first packet? So you say, it's a SYN packet. Okay, what else? Then you are like, okay, there's something else apart from SYN packet. Now let me show you guys, what is it in the SYN packet? See, this is the transmission control protocol, right? Open this up. You see the source port. Okay, everybody knows that theory. Destination port, everybody knows that. Fine. Okay, now let's have a look on over here. Do you see this sequence number? That's 0. Okay, then you have a sequence number which is raw, and then you have a good number, right? See, this information, the raw information, okay, this information is basically the actual number, the actual SYN packet or SYN number which is going 964510885. But what does the Wireshark do? It basically knows that, okay, this is the starting of the packet, this is the starting of the three-way handshakes. So to make it easy for the user or the administrator who is looking into it for troubleshooting, let me make it easy for him. So it says 0. Okay, now it is also telling you that the next sequence number, see, anything which is in the bracket, this square bracket that you see, this is Wireshark. This is not the actual packet. Okay, this is Wireshark way of saying, this is what I predict, or this is what I got to know from the packet. Okay, all right. So next sequence number is 1. We all know that from the basics of the three-way handshake, there's a SYN, there's a SYN-ACK, and an ACK. So there's always a SYN packet going on. SYN plus 1 is acknowledgement, right? So it is going to show us that. Then it says, so it also shows you the acknowledgement number, right? Then look at the length, the number of the byte which the TCP header is taking up. Okay, it also shows you the window, how much size is the window. Okay, TCP window. Now look over here. Do you see this option? This is the most important section in the TCP SYN packet, or the first packet. Okay, do you see this TCP option, maximum segment size? Have you guys heard about this maximum segment size, MSS? Anybody has heard about this? If anybody has gone through the TCP header, you might have heard about this, right? So the TCP header, right, has information about MSS. If you guys have not about this maximum segment size, see, maximum segment size is basically the amount of data that the TCP header can take it up. Okay, it's the amount of data that a packet or a packet can basically take up when it is sending the information Okay, so maximum segment size is actual, the original, the raw data, nothing else, nothing additional, nothing headers, no, nothing. It's like an Amazon package. You remove all the headers and you get the actual product that you have. So that is MSS, maximum segment size, 1460 bytes of actual data, whatever you're trying to send. Okay, then you have TCP no operation, then you have TCP window scale. Go and read about this. Maybe in the couple of weeks we'll have another session. Maybe then I can talk about this in detail, but go through this, because if anybody who wants to go to to level 2 or level 3, you are not only expected to know TCP handshake, you are also expected to know this. Okay, because this is where they gauge that how much information you know technically, and if in case something goes wrong, you know what to look for. Okay, so this is the first packet which goes, and this is the information which is being shared with the client and the server. Okay, all right, now let's have a look into the second packet, SYNAC. Okay, now in the SYNAC you can see the same information again, TCP port 80. So obviously it's coming from the destination server, right? So I know this 80. Okay. Now drop down, look over here, see the options. It is also giving the same information. See, it is like a negotiation, like just like two people talking to each other. Hey, you know what? I'm going to use this protocols. I'm going to use these many options. And the other person says, okay, I'll also go ahead and use the same information so that we both are in sync. That is how actually the TCP three-way handshake works. This is the way TCP three-way handshake works. Okay. So the next time, whenever you are talking about three-way handshake, you can always, maybe a little bit boast around with the engineers that you have. Hey, you know what is the first, what is the thing that also goes with the SYN packet apart from the SYN segment? So you can say now, okay, the maximum segment size gets negotiated, the no operations, then the SAC. Okay, just give you one liner. No operation is nothing. It's like, so have you seen that whenever there is an Amazon package and if there is an extra space, they put the bubble wraps and the thermocols and all that stuff? It's exactly that. No operation is basically there's nothing there. Okay, it is just filling up the empty spaces in the data. Okay, understood everybody? Yes, no? Yes, good. Okay, now there's something which is called a SAC. So I cannot give you a one liner to the SAC, but understand one thing. In a three-way handshake, you all know that there is a SYN, there's an ACK, there is a SYN, there's an ACK, SYN, ACK, SYN, ACK. It goes on, right? So sequential acknowledgement is also the same thing, but consider a simple situation over here. We are basically a little less on time. Just a one-liner, quick. Okay, so PCA, PCB, okay, traffic going in, SYN packet, acknowledged, data, again, acknowledged. Okay, now let's say for example, this guy sent two packets. Okay, SYN1 and SYN2. Okay, but this guy acknowledged just one. Okay, so what will the A machine will do? A machine is not going to send the next packet. What it is going to do is it is going to again send S1, and it is again going to show send S2. Okay, if this guy sends S2 as an acknowledgement, okay, then the A knows that, okay, my two packets are being sent over. Okay, but the problem is that I have to send the whole information. I have to send one as well as two. Okay, sequential acknowledgement, what it does is that as soon as I send one and two, right, the acknowledgement which I'll get, right, the acknowledgement would be a little different. Let's say for example, I didn't get the two. So what I'll do is I'll give the sorry, I'll give the acknowledgement, but I'll say 1.1. So S1, okay, S1.1. So I already got the first packet. So I know that, okay, the B machine only got the first packet, it didn't got the second packet. So what I'll do, I'll not send the whole packet once more, I'll just send S2. So now this time the acknowledgement will be S2.2. Okay, then it's just a number game, right? So do not think that it will always be 1.1, 2.2. What my point over here is, let's say for example this is 100. Okay, so this will be 100. If this is 200, this will be 202. Okay, my point over here is that acknowledgement will always be for the packet which was dropped, which never made it to the machine. Okay, that is what a sequential acknowledgement is. If you're not able to understand this clearly, it's absolutely fine. I do not expect you to get all this information right now, but go through this, read through this. Okay, it's very, very interesting. And whoever who is trying to make it to L2 or maybe L3, you guys need to know this for sure. Okay, now so this is basically when you are working with a three-way handshake. All right. So this you can see SYN, SYNAC, ACK, right? Look over here. This is the first, second, third, fourth, fifth, sixth packet. Look at the sixth packet. You see get Wireshark labs alice.txt http 1.1. So if I'm taking a capture and if anybody is basically using a plain text protocol, I would basically know what the guy is doing as well. See, in the internet protocol, if I decapsulate the internet protocol, I get the transmission control. If I decapsulate the transmission control protocol, I get hypertext transfer protocol, which is HTTP, right? If I decapsulate this, okay, I would basically get the information about what we saw. Okay, it also shows me that, okay, this is the URL, the request, information about the Windows machine, information about the time, information about the HTTP protocol number. This is more than sufficient for me to understand how exactly what user is trying to access what. Okay, now this is just for the HTTP. This also work for HTTPS connection. Okay, but that's a little bit complex. We can take another session for that, but it's a little bit complex, but it is absolutely possible, of taking a capture of the HTTPS connections as well. Now, just to give you couple of quick if in case anybody who's going through any courses anywhere, maybe a firewall course or a network course, and you want to understand however all these things work, you can basically deploy your own setup. Go and Google search for something which is called as EVE-NG. If in case you are already aware of it, great. If you're not, you might need 8 GB of RAM if in case you have a laptop with you. That is more than sufficient. It is just like Packet Tracer GNS3, but much more advanced. You would be able to do a lot with this. Let me go ahead and show you the lab that I have. The reason why I'm basically showing you this is that if in case you want to understand how firewalls is working, what is the communication which is happening. See, this is my firewall. Look, a FortiGate firewall, there's an IPsec VPN going on, there's a switch, there's a Linux machine, there is a Windows machine. You can basically perform all kinds of practical labs over here. But let me show you that. I'll open up this firewall, the CLI of this particular firewall, and I would take a capture of this particular firewall. Okay, so let me go and admin password. Okay, now do I have connectivity? Let me go ahead and check this quick. Execute ping 1.1.1.1. Do I have connectivity? Yes, great. I have the connectivity. Now I want to know what exactly is happening with the firewall. What is the firewall trying to communicate? Okay, now just looking in this picture, I will not be able to get any information. Just looking at the CLI, I will not be able to get this information. But if I right click, go on the capture, okay, see the ports, these many ports I have on the firewall. If I click on it, I would be able to start a capture. Okay, I already have a capture running actually. So let me go ahead and see that. Maybe it got closed. Okay, let me try this again. Open. Okay, it's opening up. Okay, now the Wireshark would be able to open up the interface that we are using on the firewall. See, there you go. Okay, now what is happening is, let me show you once again. I have a firewall, local FortiGate. This is connected to the internet. Okay, now just by looking into the CLI, I am not really sure what exactly this firewall is doing. Okay, but if I go into the Wireshark, okay, and look for over here, I know what exactly this firewall is doing, what information is trying to send over to. Okay, so as of now, it is basically, see, 10.10, that's the IP address of my machine. Okay, let me show you. So get system interface, that's a command, do not worry about it. Okay, so see 10.10, right? Port 1, right? Look over here, 10.10. It's trying to go to an IP address of 239.255.255.250, right? msearch HTTP 1.1. I can look for the simple service discovery protocol. It's trying to discover devices on the network. See, getting all the information over here. Okay, I even know what port is being used. Destination 1900 port used. Okay, now look over here. There's a standard query for login.windows.net. Fine, no problem. Okay, now Microsoft, you can see the query is going on for that as well. Now let me do one thing. Let's make this interesting. Okay, now execute ping. I need the website's name. Let's say www.google.com, old and famous. Ping. I am getting the ping, right? So I should also be able to see that information over here. Let me go ahead and stop the recording. Am I able to see this? Yes, here we go. See, once you are going through or practicing through the Wireshark, if you're taking if you're doing practicals on the Wireshark, slowly and gradually you would be able to, just by looking into the capture, and you would be say, hey, you know what, that's the capture, that's the packet number. Okay, so see, I have the 10.10, it's going to the DNS standard query google.com. I have the DNS packet over here. Let me open this up. Okay, I know the packet number response is in 52. Okay, standard query. Okay, request answer. See, 172 is the IP address. Now, what is the next expectation? The expectation is that what I did was I ping, right? So the DNS resolution was done 172.217, right? Same IP address. Good. Now the next packet should be ICMP, right? So let's see. There you go. ICMP packet. It's basically going to tell you everything. Okay, look over here. Internet control message protocol. Look over here. There's a lot of information. I would highly recommend go through this ICMP. How does ICMP work? Because let me tell you one thing, guys. If you know how does ICMP work in the Wireshark, if you know how TCP three-way handshake works in the Wireshark, let me tell you, you will not be able to hesitate anywhere whenever you're going through an interview, and if the guy is trying to confuse you, will not hesitate. You will know what exactly happens because you have seen it with your own eyes, right? So this is the information that you should know. Okay, look over here, the identifier. So this is just like an identification for the system so that it knows that, okay, which packet is being used for which packet. Okay, so you can see the ICMP ping request, then I have the reply. Okay, request reply, request reply. Okay, so I know exactly what the through the Wireshark, what exactly the firewall is doing right now. Okay, you can do this, you can create your lab, you can do this on your LAN PC as well, you can use this on the Linux machine as well. If you always try to do your practicals with the help of this Wireshark and EVNG, you'll not only know theoretically what is happening, but you'll also know what exactly is happening on the network level, on the layer 3, on the layer 4, on the layer 7. And if you know, and if you keep these captures, if you save, you can save this as well. What I used to do when I take a capture, and if I know that, okay, how exactly this thing is working, go to the file, click on save as. Okay, and it is going to basically save this information, whatever that you want to give this name. Let's say firewall ping. Okay, packet. That is it. Click on save. That is it. You have a working set of packet capture of how exactly a firewall is able to communicate with a particular destination. Okay, so this is how keep your learnings. Maybe in the couple of months you would be able to understand all the protocols, how exactly everything works. Okay, you don't have to cram it up, you do not have to Google search, and you do not have to look for theoretical session of how things work. Just take a Wireshark capture. You would be able to understand all the basic networking concepts, and once you are done with that, you will automatically feel within 2 months or 3 months you are getting better at your job. You would be able to understand how exactly the packet works, network works, how exactly you want to look into. If in case you know that, okay, if I'm sending a packet, if you do not see a reply back, you know that I'm not getting a reply, the machine is not getting a reply, and now this packet is on the firewall. So if the traffic is going through the firewall and you're not getting a reply back, you know that this is not something which is a problem on the firewall. It's a problem on the upstream device. If you have a router on the next, next session, or if there is a upstream router, you might have to look for whether the traffic is getting blocked over there. Okay, or maybe the next server would, if it is trying to send the packet response or not. Basically, you will be able to pinpoint where the problem is. Okay. All right. So guys, that was it for today. I tried to put a lot of things in the 1 hour. Maybe in the next session we'll be able to extend a lot of things. Okay. Till that time, I say a bit, and over to you. And this is from my side. Thank you,
Right.
everyone.
Thank you, Rakshit. So guys, a quick feedback on your screen. Please feel free to quickly rate our expert today. Rakshit, it's been a pleasure having you on our platform, and we definitely want to look for more sessions with you in the near future, because I think a lot of students have reached out to kind of have more doubts cleared around. So we will ensure that in the future, our topics are kind of more extensive, probably go beyond the 1 hour mark. But apart from that, thank you so much for being on today's platform with AntWak. We really love your collaboration, and we look forward to having more of you on the AntWak platform. So guys, the recordings will be available on the AntWak website. If you go to the AntWak website, on the top right corner, you'll find something called upcoming masterclass, and the video will be available in 2 to 3 days. People who registered with their email address will also receive the respective certificates of their email. Apart from that, thank you so much for your time. Thank you so much for attending. Thank you so much once again, Rakshit. It was a pleasure to
Thank you.
And you take care of yourself, and thank you guys for attending. Cheers.